Hello, our lovely friends. How are you? It's 2:00 a.m. here in Hsinchu, Taiwan. Good morning. Thank you all for you being here today. We miss you so much. It has been a couple of months due to the COVID-19 started to flip up our lives. That's why we see you by a live stream here. To review the past year, we see the LED industry still have activities. For the outdoor, let's see it. It's a LED outdoor drive-in movie theater. Some of them plan to implement the lighting DJ show. It will be very amazing. For the indoor, the 4K 0.75 millimeter has new design to 8K, the pitch down to 0.39 millimeter. Today, we will talk about six elements about Macroblock new basics. Let's cover the applications. For example, low grayscale. It's very important, especially for the night, for the dark. Another topic is about the new driver IC solution for mini LED and micro LED. The first session will be hosted by Raymond and Albert. The second session is hosted by Hugo and Anson. During our live stream, the chat room is open for Q&A, discussion, and chat. Okay. The last, we will have online interactive Q&A time. Raymond, me, and Hugo. So let's get started. Welcome, Raymond, Albert. Hi.
Hi, thank you, Sandra.
Hello everyone, this is Albert from Macroblock service team. It's my pleasure to have an overview with you. Recently, there's more and more fine-pitch LED displays such as TVs, movie backdrops, or wearable devices. Therefore, we especially define the new basics which contain 6 elements in order to meet the market requirement on LED display. The 6 elements of new basics are image quality, minimum gray, HDR-Optimized, 64 scans, low power, and highly integrated. I'll let our technical support team, Raymond, to explain more. Hi, Raymond.
Thank you, Albert. Yeah, in the past few years, we all have a booming business in LED display, especially the indoor fine pitch application. Macroblock provides the Hawkeye solution to make the fine pitch products with high quality and visual performance. However, some visual defects come with this time multiplexing solution, and you will take them as the challenges in designing your products. So we listed all of that as 7 challenges, like ghosting effect, color shift, LED dead pixel, high contrast interference, and so on. So to overcome those challenges, we build the relative functional blocks inside our Hawkeye LED drivers. And with all of the works get done, we will have the image quality as a basic. And for more detail about this basic, please download the technical article from our website. Okay, and today, we want to introduce a new standard called minimal gray. The minimal gray is the minimal brightness level in nits, and it composed all the brightness levels of all LEDs to realize the picture and video in the PWM-based LED display. And with this feature of minimal gray, we will have a smooth gradient performance, as you can see the picture at the bottom of this slide. Instead, without the minimal gray feature, as the picture at the top of the slide, it appears to lose lots of details in the low brightness area. So when we're talking about the minimal gray, we also had to make sure we measure the low grayscale performance at the same brightness level, and we have to still keep the same image quality. And following, we will show an example of how the minimal gray is measured. Please look at the slide. The two displays are set at the same condition. The gray level 1 with the same brightness level 0.05 nits. But the uniformity of the displays are totally different. The display on the right-hand side is designed with Macroblock's driver IC MBI5264. And we can tell that the display is much more uniform at the low grayscale. So we can expect better display performance at the low brightness and more details at the low grayscale on this display.
Well, I noticed something important here. Nowadays, we always care about the maximum brightness, like 1000 nits or 2000 nits. And we don't look at the brightness and its performance of low grayscale.
Yeah, exactly. Technically, the minimal gray feature of MBI5264 can provide a more precise gamma curve, which is very close to the gamma 2.8. Thus, the original video is truly reproduced in the LED display. And we will have a real gamma curve measurement of this MBI5264, which is designed in 1.25 millimeter pitch, 16-bit color depth, and 4K visual refresh rate to ensure the MBI5264 is the 16-channel LED driver solution with the best video quality in the market.
Hi Raymond, I have one question since you mentioned the precise gamma curve. Is this also affecting the HDR of the whole LED display?
Yes, the minimal gray performance will contribute to the HDR performance. And we all know the HDR solution is very popular now, and Macroblock wants to provide more advanced technology in this field, which we call HDR-Optimized. The LED display with high grayscale like 16-bit, the display sharpness and uniformity will be better than the traditional 13-bit design. Please take a look at the yellow dot area. We recognize the 16-bit grayscale can provide higher display quality than the 13-bit grayscale.
Hi Raymond, I'm afraid that some of our customers still curious about the HDR-Optimized. Please let me introduce through the demos. Today we provide two demo cabinets in pitch 1.25 millimeter. One is MBI5254, another one is MBI5264. Both of them can provide 0.5 to 20 milliamp at 4.2 voltage and support to 64 scan. This one is MBI5254, and both of them are recommended for pitch 1 to 4 millimeter. And this one is MBI5264. Please stay closer and look at the detail of the picture. With MBI5264, the dark will be darker, the bright will be brighter. The main difference between MBI5254 and MBI5264 is that MBI5264 can support HDR-Optimized, 16-bit grayscale, 4K refresh rate, and over 20,000 contrast ratio. Hey Raymond, could you please tell us the secret of HDR-Optimized?
Of course. Yeah, the key of the HDR-Optimized technology is the PWM enhancement function. And how to reach the 16-bit design, here is an example. In the 32-scan design with 4K Hz visual refresh rate, it requires the grayscale clock at 151.8 MHz. And it is really difficult in the bold design. And with the PWM enhancement function, the grayscale clock will be down to 95.9 MHz, and the 16-bit can be realized in the LED display. And also, there is no PWM grayscale clock, G clock, on the LED bulb, just one data clock to drive the whole LED display. So we will have additional advantage at EMI testing result. And here is the chart that show our HDR-optimized solutions from pitch 60 mm to 0.4 mm. And this chart shows how to pick up the right LED drivers for your multiple scan solution based on different applications. For less than 32 scans, MBI 5850 and 5359 are recommended for pixel pitch range from 6 mm to 0.6 mm. For over the 32 scans, the MBI 5264 and MBI 5864 are recommended for pixel pitch range from 4 mm and down to 0.4 mm.
Hey Raymond, some of our customers think that 32 scan is enough for their design. Why you suggest over 32 scan?
It's really a good question, yeah. This year, we have more products provide up to 64 scan design, which are good for your narrow pitch products. I will talk about the advantage in comparing to the 32 scan solution. First, the driver counts will be half in 64 scans, and therefore the PCB design and layout will be flexible and clear. And sometimes you may need 36 scans design. On the other hand, the 64 scan LED driver will have the benefit to reduce the power consumption due to the less LED driver used. Here is an example to compare MBI 5253 with 5254 used in pixel pitch 1.5 mm LED modules. This slide shows with the same resolution 108 by 96, the 27 scan designs with 72 pieces, MBI 5253 will be upgraded to 54 scan design with just 36 pieces, MBI 5254. And also by the less component use, even the 6-layer PCB will be simplified to 4-layer PCB. And we will have a power consumption pie chart here. The total power consumption from the driver is reduced by 41% with MBI 5254. Data Albert will show you how to choose the right 64 scan solutions.
Thank you, Raymond. I'm pretty sure that everyone knows the benefit of the 64 scan driver now. Therefore, I would like to summarize into one simple chart. The 4 listed driver can support scan and apply for different pixel pitch applications. MBI 5754 and MBI 5864 have the basic of low power. Especially, MBI 5864 is the most powerful driver which can meet all 6 basics. Let's take a break here because there are some questions for us right now. Okay, number 1, what is the difference between MBI 5153 and MBI 5254?
Okay, yeah, the MBI 5153 is our best selling product, and it has superior image quality at 32 scan design. And the differences from the MBI 5254 is that we can have a higher scan number, up to 64 scan. And also, we will have an upgrade image quality. And besides, we put the low power solution in the MBI 5254, so you can have a low power feature in your LED display.
Thank you, Raymond. Number 2, is there any recommended common cathode LED driver solution for semi-outdoor LED display?
Okay, yeah, there should be this product, MBI 5754. And this driver can be used for semi-outdoor application, depends on different application. And we have one customer called ROE has already adopted this MBI 5754 for mass production in their pitch 4.6 millimeter products.
Thank you, Raymond. Let's get back to Sandra.
Thank you, Raymond and Albert. Wow, we got much information. They talk about the Macroblock new technology and LED display quality and performance. If you have any question, please put your questions in our chat room. Our colleagues there will answer you immediately right now. Okay, this session, Anson and Hugo will introduce MBI's new driver for 48 channels. It's highly integrated up to 64 scans. Another topic is about power saving, low power. Hi, Anson. Hugo.
Hello, Sandra.
Hi, Sandra. Good morning, good afternoon, and hello to everyone. This is Anson Lin, Regional Sales Manager. In today's live stream, sometimes I will pretend to be an end customer in the real market to raise a few questions. Normally, we can reduce driver chips through time multiplexing. Times 2, we can reduce half of the quantity. Besides of this, is there any way can furthermore to release more space in the backside of the PCB? Hey, Hugo, any idea for this?
Hey, Anson. Hello, everyone. My name is Hugo. I'm so glad to be here talking about highly integrated. When it comes to highly integrated, maybe some of you will wonder what highly integrated means. The definition of highly integrated means to integrate 3 components, driver IC, MOSFET, and logic IC in one package, 3 in 1. Since we know components on PCB are very crowded, as pixel pitch is less than 1 millimeter, the PCB layout is going to face a huge challenge. So, Macroblock highly integrated LED driver can help save space issue on PCB.
So, let highly integrated technology solve the problem of space limitation on the backside of the PCB to push the sub-1 pixel pitch to become real. But things are not that easy. There must be other key technology that sub-1 needed.
Yes, you are right. A small driving current is the other important factor. There's a chart to show the relation between pixel pitch and LED current. Here, we can realize when pixel pitch becomes more narrow, that requires smaller LED current. So, LED driver must have excellent small current accuracy to fulfill extremely small current applications, especially pixel pitch is less than 1 millimeter. For mini LED application, pixel pitch ranges from 1 millimeter to 0.7 millimeter. MBI 5359 and 5759 are the perfect solution because their minimum driving current is 500 microampere. For micro LED application, pixel pitch ranges from 0.7 millimeter to 0.4 millimeter. MBI 5864 is the best solution because its minimum driving current is only 100 microampere. The next page, I would like to talk about scan sharing. What is scan sharing? Scan sharing means LED driver has its own MOSFETs inside that can be shared with other MBI 5864. From this slide, you can see the comparison between traditional scanning and scan sharing. Using traditional scanning in 64 by 64 pixel, it needs 8 pieces of MBI 5759. Using scan sharing, it only needs 4 pieces of MBI 5864. So, LED driver with scan sharing technology only use IC number in half comparing with traditional scanning. Therefore, the advantage of scan sharing is to save IC numbers, getting more space on PCB.
Well, I noticed this new part number, MBI 5864, highly integrated with scan sharing technology. At the same time, providing minimum driving current, 100 microampere. I'm curious, what is the smallest piece of pitch that it has so far?
Here, let me show you a real case. As you see, this module uses MBI 5X64 solution, and it is the first micro LED display in the world, which has a very narrow piece of pitch, 0.39 mm, and the package size of MBI 5X64 is VGA 6 by 6 mm, which is very compact. Hey Anson, I think you will be interested in the next topic. I'm going to talk about the power contribution when piece of pitch is less than 1 mm.
Wait a minute. I know power consumption, but is there any mistake on this chart? We use a lot more LEDs than drivers, especially when the piece of pitch gets smaller. How come the power consumption of drivers is larger than LEDs?
Well, it depends on the piece of pitch and applications. Let me put it this way. When piece of pitch is larger than 1 mm, LED will consume more power than IC. If piece of pitch is less than 1 mm, IC will consume more power than LED. There's an example. A cabinet, its piece of pitch is 0.625 mm. This pie chart shows IC drivers consume power up to 76%, and LED just consume around 24%. So here we realize the power consumption issue for IC drivers already become an important matter when piece of pitch is less than 1 mm.
Okay, that makes sense to me now.
Yep.
Since the power consumption become important, I believe that Macroblock have some low power solution.
Yes. When it comes to low power, there are three methods to reduce power consumption. The first method is to use common cathode LED driver, which drives different color LEDs with different voltage. Generally speaking, 2.8 volt for red LED and 3.8 volt for green and blue LED. The second method is less IC power. That means the IC driver will take effort to minimize IDT current. The third method is to enable dynamic plus power saving function, which can continue to reduce power consumption by output the channel. Even LED panel is displaying contents on the screen.
So today we cannot only save power by IC itself, but also can save power by channel because we have dynamic plus technology. But today we talk about the serial a lot. Do you have any testing can prove it?
Yeah. Next, I'm going to show you both performance of dynamic and dynamic plus power saving. Dynamic power saving function is achieved by the IC. How does dynamic power saving work? It is automatically to enable dynamic power saving function when LED driver receives all zero gray data, which means the screen is all black. And then the IDT current of the LED driver will dramatically drop down a lot. There's a test to measure input current of LED panel to compare dynamic power saving of an arm. As a result, dynamic power saving arm can reduce power at least 52%. And yet, we have dynamic plus power saving, which is an upgrade version of dynamic power saving. It can save power by output the channel. When grayscale level 50, dynamic plus power saving arm can save 17%. When grayscale level 1, dynamic plus power saving arm can save more, 19%. So, if grayscale is getting lower, dynamic plus power saving can save more power.
All right, let me make a short conclusion here. In this table, all the drivers have dynamic plus power saving technology, and we categorize them by the applications: outdoor, indoor, and mini and micro LEDs. For outdoor, we have MBI 5251, and two of these have small star, which means they are for common cathode LEDs. Hey Hugo, I have a question for you. Earlier, you mentioned some low power solutions. I would like to know, is there any testing to compare Macroblock low power technology with a common cathode product?
Yep. In this slide, there are two panels. One panel on the left-hand side uses MBI 5759, which is a common cathode LED driver, and the other panel on the right-hand side uses MBI 5864, which is common anode LED driver. Two panels have the same pixel pitch, but different pixel resolution and the light number. We did a test to measure the input current of each panel. Let's test the condition based on the LED panel displaying a black image and turning off dynamic power saving function. And then we calculated power consumption by pixel. According to the result, we realized that power per pixel of MBI 5864 is 47% lower than MBI 5759.
Wow. We all know that reducing power consumption can save energy, save money, and save the world. But there's a lot more benefit that with a low power technology than you thought.
Yes, there's a chart on the left-hand side to point out the relation between LED junction temperature and LED light efficiency. To explain that, LED light efficiency will drop down at high temperatures. Here, we can understand the brightness of red LED will drop down severely around 50%. When junction temperature is 100 Celsius degrees, and green and blue LED just decrease around 25% or less. On the right-hand side, there's an LED panel to display white color. Obviously, we see there are many color shift blocks on the screen, which are caused by the high temperature of LED drivers. So, this is the reason why Macroblock emphasizes the importance of low power for LED drivers. The benefit of low power is not only to save power, but also to keep good image quality. This is a real case to measure the temperature on the surface, mini LED and IC driver. As a result, due to the low power consumption of MBI 5864, the surface temperature of the IC driver is the only 31.4 Celsius degrees, which is lower than mini LED, which means IC temperature will not cause mini LED to have a color shift phenomenon.
The point is that with Macroblock low power technology, it can bring you lower temperature and high reliability. Okay, here we are, the last page. We gave a full page of our high-end product, MBI 5864. It has so many features, and some of them are really what we recommend. Now, I'm going to wake up 5 features about MBI 5864. MBI 5864 has scan sharing technology, PWM enhancement, true 16-bit grayscale, dynamic plus power saving, and minimum output current is down to 100 microampere. Currently, MBI 5864 is Macroblock flagship product which can cover the new 6 bases. Our presentation part will stop here, but it's not the end. Let's move on to the Q&A session. Hi, Sandra.
Hi, Hugo, Anson. Thank you. Wow, we got many information here talking about the power consumption, low power, common cathode driver, and scan sharing, MOS sharing, dynamic plus power saving. If you have any questions about this, please put your question in the chat room. So now we will have our online interactive Q&A time. Hi, Raymond.
Hi, Sandra.
Hi, Sandra.
See you again,
Yeah.
Hugo. We have many questions in the chat room now. We have to answer them. Okay?
Okay.
Let's start it. Number 1. Are these new driver IC in production now? Hugo.
Yep. Now, currently, there are MBI 5254 and MBI 5754 already in mass production, and MBI 5264 will be released in the end of this month, and MBI 5864 sample will be ready in August.
Yeah, okay. I also hear that our customers already have the world's smallest pitch for 0.39. So our driver MBI 5864 can
Yeah.
use it.
This one.
Okay. We see the next.
This one.
I need 16-bit and 4K refresh rate for my LED display. Any recommended driver IC?
Okay, yeah, this is the specification as MBI's HDR-Optimized. So we already have several drivers that support this. And there will be the MBI 5359 and MBI 5850, MBI 5264, and MBI 5864.
Wow.
Those
we
those
have so
drivers.
many
Yeah.
solutions.
Yeah.
Yeah, and there are 16 channel drivers for 5264.
Yes.
The others are highly integrated driver IC.
Yep, correctly.
Okay, we see the next. What is the new basics means?
The new basis means there are 6 elements: image quality,
Low grayscale.
low grayscale, and 64 scan, and the HDR optimized, and highly integrated and low power.
Yes,
Yeah.
that is new basics Macroblock 6 elements for a very good quality LED display and performance. Let's see the next one. Hi, how can we reduce the low scanning strobe effect, especially at the low brightness grayscale values? Are the new drivers taking care about this? Raymond?
Okay, thank you for my friend Jorge give me this difficult question. Yeah, and in time multiplexing design, and there are lots of components connected to the same point to our drivers channels. So the drivers channel will be very heavy with very high capacitance. So when each time we change the scans, we will have many problems. But Macroblock provide the HDR optimized. We provide more options in the channels opening about the transition time. We can change the transition characteristic of our upper channel. And also we provide the delay option. So you can change your channel turn on, turn off. And also your scanning power MOSFET turn on, turn off time. So by these 2 options, that will be helpful to solve the strobing effect of your MOSFET switching. Yeah.
Yep.
Thank you, Raymond.
Yeah.
Love you. Okay, the other question. Macroblock have a scan sharing driver. What is the difference MBI 5864 and MBI 5850? Hugo?
For both the drivers, for the 5850, this driver can support the scan line up to the 32, but for the 5864, this driver can support the scan line over the 32. His maximum scan line is 64 scan line. So this is a bigger difference between them. Yep. And this driver, MBI 5864, is for micro LED application. His minimum driving current is down to 100 microampere. So this is a very perfect solution for micro LED application. But for this 5850, it can be used for a pixel pitch 1.0 to 6.0 millimeter.
Okay, thank you. The next question. Do you have a driver IC to support a 120 Hz frame rate Well, these questions recently we got many such like this.
Yeah, we would suggest to use the driver which features with PWM enhancement function. That would be MBI 5359, MBI 5264, you're right,
Yeah.
MBI 5850,
Yeah.
and MBI 5864. Those 4 drivers can support your high frame rate features up to 120 Hertz.
Yeah, also can get very high refresh rate.
Yeah.
Okay, the next question. Is there any common cathode display module which already in mass production now?
Yes, we do have the common cathode LED driver be used, and they already be in mass production already.
Yeah, it's
Yeah.
MBI 5754 and MBI 5759.
Yeah.
Okay, the next, how does MBI 5864 achieve low power? Because it is not common cathode product. Raymond?
Okay, when we're talking about the power dissipation, and usually they were divided into parts. One is the LED, one from the driver chips. And for the application which go into the narrow pitch, sometimes the driver parts will be rise. So by our MBI 5864, we use the new process to make this chip. So we will have a lower IDD current. And also, we use the scan shielding technology inside MBI 5864. That will be help in reducing the LED currents. Yeah, also. So about the common cathode, they usually have 5 to 10% power dissipation drop. But also with our new technology for the new IC, they will be also great for the power consumption issue. Yeah.
Okay, thank you. Wow, we saw many questions focus on MBI 5864. The next also, MBI 5864 comes with the HDR optimized. Hugo?
Oh yes, this driver has a PWM enhancement. That means he can support high grayscale level and also can provide high refresh rate. So he can meet the HDR optimized feature.
Okay, the next one, which driver IC do you recommend it for drive-in cinema? Raymond?
Okay, the drive-in cinema usually is what we call the bigger pitch, probably around the 6
2.5?
millimeter, 2.5 to
Yeah.
6 millimeter. So we will use a high current driver series MBI 5251, and the 5251 is the update version of where know the MBI 5051 already used in the outdoor display. So we would suggest use MBI 5251 in your outdoor driver-in cinema application.
Yeah, okay.
Yeah.
And next, what is the best MBI solution for message sign? I think a message sign means about the VMS like traffic sign, bus sign, and the LED sign for the street, like this.
Yeah.
So the output current should be higher. What is the driver we recommend?
Okay. For this kind of application, I think MBI 5251 is the best solution because he can drive the output current up to the 45 milliampere, and this driver also have very fantastic feature. We call it dynamic plus power saving. He can save power, so we will recommend to use this driver for the message sign application.
Does this driver also have error detection?
Oh, correctly,
Yeah, it's quite important for
Yes.
VMS sign.
So
Yes.
it would be a good update from our well-known the MBI 503A, 5039, right? Yeah.
Okay, the next question, how about the current gain at MBI 5864?
Okay, the current gain of MBI 5864, usually that we have two parts of the current gain adjustment. One is what we call the global current gain adjustment. Another one is what we call the individual current gain adjustment. So it's taken two parts. Yeah, And the range for the current game, there will be around, I remember, is around 1/8 to 200%. Yeah.
Okay.
So there is a current game. Yeah.
Global level and by channel level.
And also by channel level.
Wow.
Yeah. We have two parts of current game.
Powerful.
Yeah.
Good driver. Okay, the next one. What HDR standard comply with?
For this question, MBI has defined the HDR-Optimized as our LED display. We define HDR-Optimized means 4K refresh rate and 16-bit grayscale. So, based on this condition, we will say if LED driver can meet this both feature, we call it HDR-Optimized.
So we have the driver to recommend for our friends.
Oh yes,
HDR.
yes.
Yeah.
Many.
Many.
Yeah.
Yeah. For the
That's what we told,
5264 and the 5864 and also 5359, they can meet the HDR-Optimized.
Okay, thank you. The next one is the constraint power comparison. It looks like common cathode LED is not the most power efficient display implementation, isn't it?
Yes, in talking about the power consumption, the common cathode is not the only issues, and also that there are a lot more about how we switching the power modes and how we switching the channels. So by our new technology, the low power basic, you will experience the great power consumption features. Yeah.
Okay, the next. What driver IC recommended on pitch around 2 mm for Visual Studio? Need to work with film shooting camera.
Okay, for this kind of application, I will recommend for MBI 5850 because this driver, he can provide the high grayscale level. And this driver also has a PWM enhancement, so it's perfect for the pixel pitch 2 mm application. Yeah.
Okay,
Yeah.
great. Well, it's time closing to the end. We still have many questions in the chat room. Our team members in the chat room will keep answering our friends. So, our dear friends, we have to say goodbye, but keep safe and healthy. In this September, Macroblock have new product presentation launch seminar. We will see you in this September again soon. So, see you.
See you.
Bye-bye.
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 Bye.
Goodbye.
Guten Abend.
Goodbye.
Gracias.
Gracias.
Wiedersehen.
Bye.
Hola. Our friends
Bye-bye.
in Europe. Arigato. Also customers from Japan. Thank you, our team members, sales FA teams. Thank you.
Thank you.
Thank you, our dear
Bye-bye.
customers,
Bye-bye.
our dear friends.
Bye-bye.
See you in September.
Bye-bye.
See you in September. Bye-bye.
Bye-bye.
Bye-bye.